we have Sridhar Rao from the Linux Foundation. So Sridhar Rao is a professional with PhD from NUS Singapore and currently working as a senior architect at the Linux Foundation. He has over 25 years of experience in computer networking with more than 16 years of experience in the industry. So he'll be talking about an overview of open source networking projects. So really cool talk to hear. So over to you, Sridhar.
I cannot assure whether it'll be cool, but I'll try my best. Okay. Good afternoon, everybody. I'm Sridhar, and I represent Linux Foundation. And I really thank all the organizers for giving me this opportunity. We are in open source business, so this is a right event for us to be here and talking about open source. I'm assuming quite a few are familiar with Linux Foundation. Has anybody not heard of Linux Foundation at all? Good. Though it's not true, my colleague is Linus Torvalds. Okay. So Linux Foundation is the world's largest open source collaborative ecosystem thing. So what we do is we manage open sources, right? And maybe I'll just go. So when we talk about open sources, Linux Foundation is like very choosy with respect to picking these projects. So if you see in GitHub, you will find a lot of so many other projects which has number of how much of value for each individual project. There are very, very, very few projects that have really some value for the community or for the entire ecosystem thing. So Linux Foundation tries to identify and pick those specific projects. And the main, our job is try to fit in these projects that we bring in to a set of sub-foundations that we have. So Linux Foundation is nothing but a foundation of foundations. So within Linux Foundation, we have a bunch of other foundations, and not just the software projects. We range from starting from the data to the standards and specifications. So we might be stepping onto IEEE's domain, but why not? So we are trying to come up with open standards and other things and see how we can do kind of a thing. So what we do is for us, if a project doesn't become a product, it's a failure for us. Okay, we are paid, and our whole thing is always focused on how to take this project to a product. Okay, any successful project, right, in open source, there are products around that. Without a products around these open source projects will not survive. Okay, so our main focus is always take this open source project to a product. Okay, that's our job. That's what. So yeah, maybe you would have seen how. Just to give an example, those who are familiar with PyTorch, right? A few years back, before it joined Linux Foundation, TensorFlow was really kind of dominating over in the domain. People who have been working on this AI tools and things last 4 or 5 years, you would have seen this transition, how PyTorch has become like dominated now of late since it joined Linux Foundation. So that's what Linux Foundation does. They have a huge teams around for every project and try to work on how to take this project to a product level. Okay. So don't worry about this. As I mentioned, we are a foundation of foundations. We have set of horizontal foundation that applies to all the other various projects, and we have very specific vertical foundations. Linux Foundation networking, that where I'm representing, is one of those verticals. Whereas AI and data, it applies to various foundations. And also the cloud native part and the open infra, it applies, it's a kind of a horizontal foundation. So we categorize this foundation to a horizontal, whether it's an horizontal or it has its own vertical. Okay. So I think you might be familiar that Linux Foundation launched Linux Foundation India recently. Because I'm kind of only employee now, I'm the director of it. So if you have anything about Linux Foundation India, please reach out to me. You will be seeing soon in a week's time. We'll be going and trying to reach out to all the volunteers and other things. This year, our main goal is to work with government organizations. We want to help our government organizations in uh, these domains of Indian government organizations to help them to consume open sources and, if possible, if they can contribute to open sources. Okay, so our goal for this year is a government organization. So that's where we want to now. Who will be doing this activity with for the government organization? We need volunteers, right? So we will be reaching out to people like you, or if you want to contribute and help our government organizations to consume these open sources, and how do we like bring people together? So that will be our goal for this year. So, key takeaway, if you don't want to listen for next 20 minutes of whatever I'm speaking, just because I represent Linux Foundation, I don't want to restrict to the projects that are part of Linux Foundation because it's an open source event, and we want to focus on projects that are related to networking domain. That's my topic that I was talking, and I want to also cover the projects that are not part of Linux Foundation also. Okay, because there are projects that are not part of Linux Foundation related to networking and doing very well. Okay, so this is the point I just want to highlight. I'll be focusing again because they are paying me. I'll be focusing on the Linux Foundation networking projects, but there are very important ones. I don't know whether you can see. I'll just tell. They kind of fall under these 5 different buckets, kind of a thing. One is on traditional routing and network operating system, where FRR routing. I don't know how many of you used FRR routing. That's one of the really good project. And network automation and management, NetBlocks and Nornir are the very popular projects. And for security, OpenSense, and if you are focusing on building a security or firewalls using a FreeBSD based thing, OpenSense is the one. And OpenWIS for OpenWRT thing, and for embedded networking, WireGuard. Okay, so these are projects that are there, but specific for you students, this is my kind of a key takeaway. Please focus on the current trends that are happening in the networking and some of the example projects under these current trends. Okay, so if you forget all the other slides that I'll be talking, my request is to please focus on this particular slide only, because I want you to focus on the trend. Starting from trend, come to the project kind of. Like what's happening in networking as of today? What's new? What's really hot now? Where I want to spend my time and where I should contribute my time and energy and contribute to the code. You should focus on the trends first. Okay, and based on the trend that is happening, you can pick and choose the projects around that. So if I want to just list the top 5 trends that were related to networking, the first one is on the 5G and 6G side that are happening, 5G RAN and core, especially 6G. I'm really sorry if you're not familiar with all these Gs. It's a telecom term. Don't worry. 6G, what is 6G significantly different from 5G would be the adoption of AI, right? So if you are interested in AI networking, which I will again focus on, please telco domain, and if you're interested in a domain of telecom, this is the one which you should be focusing on. I'll be, because I as of today I contribute and work on open sources related to 5G. I will spend slightly more time in future slides. But that is the current trend. Whether ORAN will be successful going ahead, we really don't know. There are people against it. There are people for it. Nokia recently changed their whole strategy. They were all pushing for that. But it's the thing that everybody wants it, right? And the next one is AI in networking. Again, as I said, this is very related to even for telecom and enterprises domain. How to do the AI networking part. Okay, so if one of the biggest challenge working with the telecom with AI networking is the data set. You cannot get data set thing, right? Because of regulations. Even though they would want to share the data, they cannot share the data. because of the strict regulations telecoms have to undergo. Government has regulated you. Any consumer data is there in it, they cannot share it. So without telecoms sharing the, without these Airtels and Geos sharing the data set, you cannot build any AI solution, right? So as a researcher, as of today, it is very, very, very difficult. So what we do is we use GANs. I don't know how many of you are familiar. I've used GANs before. We take a sample data set and use GANs to generate synthetic data sets. Okay, that's a very, very another interesting topic as of today. And also anonymization. Because telcos are hesitant to share the data set, you can come up with anonymization solutions for anonymizing telco data set and share these anonymization solutions with these companies and see if they can use the tool and share the data set with you. And the next is the networking for AI. It's like AI for networking and networking for AI. So when you're doing the AI in a data center and everything, what should be the networking solution? How it should look? So the data center fabrics. I'm really sorry if you're not familiar with the data center networking. You can go back and look at it. Data center fabrics, the leaf, what is this? Leaf and spine architectures and all those things that are there in data center. Projects like Sonic are really doing really well of late. Next is cloud native networking. So if you have used Kubernetes, how many of you have used, I'm assuming most of you are using Kubernetes or used Kubernetes in one form or the other. In most of these enterprise applications, right, you really don't bother of interfaces for these pods that you run. Because you just start a pod for a web app or anything, you have the one interface, it works fine. For network related functions that what we call like a router or a switch or any of these networking firewalls or all these networking device, right? They need multiple interfaces. Okay. When you need multiple interfaces, and also when you look at the complete telecom end-to-end network, they will have to run on multiple Kubernetes clusters. So you will have to connect one pods running on one Kubernetes cluster to another cluster, not with just one interface, but multiple interfaces. So this challenge of multiple interfaces will be initially be new for those students who are not familiar with the multi-interfaces in Kubernetes networking. But that's a very, very interesting area that's happening. You have to use Multus and various other things to support that. So Kubernetes, networking in Kubernetes for telecom or networking use cases is a very, very interesting research area that's happening. And last is still foundational IP routing, like especially the BGPs and all those things. BGP is everywhere now. OpenFlow is more or less dead. I spent a lot of time on that, unfortunately, but yeah. BGP is are still via VXLANs, VLANs, EVPNs. They are still a hot topic. Okay, and especially when it comes to open sources. That's why I mentioned for IP routing, normative IP routing, FRR. So if you want to try and learn routing thing, FRR is the one which if you want to try and contribute to that also. So these are the top trends in networking that's happening today. And those are the example projects that you would want to focus on. For the cloud native networking, especially Cilium. I don't know how many of you have used Cilium, have come across Cilium. That is one of the really, really hot topic today. If you go to Cilium GitHub thing and see number of stars and how much of activity that's happening, really, really hot topic because it's based on eBPF. So if you're using and working on eBPF thing, you will understand how it's solving a lot of problems around networking, security, and observability. In these three domains, eBPF is really, really hot nowadays. So if you're working on in any of these three domains, and if you're not considering eBPF, my request is to go back and look at this eBPF. Okay. And cloud native networking for 5G RAN and core, there are a bunch of open sources. In India, a year back, we started a project called iOS MCN, India Open Source Mobile Communication Networks. I don't know how we came up with that thing. So this iOS MCN is a project that ISC, IIT Delhi, and CDAC are together and doing it. If you want to contribute to that particular project, please reach out to me. Okay, so if you want to work on telecom, if you want to work on open sources in the domain of telecom, please reach out. Okay, and the projects are SD Core, SD-RAN, OAI. In 1 month, there is a new project that's coming up to Linux Foundation that's called Okudu. It's not the Telugu Okudu, it's OCUDU. So there, what US government, they spent like $30-40 million and kind of bought one software and open sourcing it. So that's the thing that they are doing just to facilitate this open source thing. This CUDU part was the only piece that was missing in 5G network. If you want to build, if you want to deploy a 5G network, private 5G network in your campus, you can do it in a 1 or 2 days time if you have a server. Okay, so so it's that easy now. You can deploy your own private 5G. You can use your mobile phones, connect to that private 5G and talk to each other in just maybe hardly 1 day if you sit together. So open sources, especially in this 5G and 6G, has really revolutionized. One of the most difficult part was the CUDU. Even that will be fully open sourced. We have OAI and other things, but they are not really open source. They have a lot of constraints. But the OCUDU from the US government, the Department of Defense from US government, so you will be seeing it in a month's time. Okay. So please, if you're interested in working on the RAN domain, look out for OCUDU. On the SMO and the RIC, that's where I spend most of time because of I don't really have the radio units and those kind of hardware with me. I can mostly focus on the SMO part. If you are not familiar, what is this SMO? What am I even talking about? RAN and core and other things. If you're not from telecom network, don't worry. I'm really sorry for that. But I'm just trying to summarize what are the top trends and what are the really projects that you should focus on. Even if you don't listen to me for the next minutes, please just look at this slide because this is kind of a summary slide for me. Okay, and telecom automation, ONAP, it used to be a terror, but of late they have changed it and kind of simplified it. They have kind of removed everything and made it a small bunch of projects and made it really easy to do that. So what this SMO and ONAP, let me give you an analogy kind of a thing. Traffic, you're all familiar with the traffic, right? Once the roads are built and the vehicles are allowed to move on those roads, what people do is they'll start monitoring. So you would have seen operation center, the police uses, right? So that operation center that police use is a very equivalent of SMO or OAM in telecom. Okay, it's exactly like that. So if you go to the OAM or SMO where it's running in a telecom, for example, in Reliance Jio, they have like a 5 to 6 times bigger than this room and a huge screen with 100-200 monitors, more than 200, more than 500 monitors there. So because they will be monitoring each and every cells, towers that are there, for each tower, how it is behaving and everything they'll be tracking. Just like how the police monitors the traffic, we in telecom also, we will have to monitor each and every tower that's there. Okay. And AI for networking, Sonic, high performance data plane, DPDK, and eBPF, as I mentioned. Again, if you're not working on eBPF, but if you're looking at security, observability, and networking, please take a look at eBPF. Netbox and Nornir and OPNSys. Okay, so this is the thing I have spent. I don't want to go too much of LFN projects that are there. I just want to share how we organize our LF networking projects related to networking, right? It's easier to look at when we talk about networking, right, how the networks are laid out in all our country and how the people use it, we can organize it based on the very user edge, the enterprise user edge, the service provider edge, and the cloud kind of. So if you don't worry, the enterprises is where your campuses, you're within the buildings that are happening, right? And the user edge is between you and, for example, the RAN comes under the user edge, right? So you would have seen all the towers with antennas, right? So right next thing that connects to the antenna is called as radio unit. It's called as RU. Okay. Usually these RUs used to be right near the antennas. Nowadays they kind of slightly move it away, kind of. So the idea was to, there used to be a lot of boxes around for this network. I don't know how many of you remember, we used to have something called, what is that called? All this BSNL and everybody used to have this offices thing. I really forgot that term. Nowadays, all those offices, exchange center or telecom exchange center or something they used to call that. Now all these things have become data centers. Because the trend of virtualizing, whatever we're running in a box, were cloudified. They are now running as first they started to run as VM, now they are running as a containers. Okay, in the edge now, only the RU component, that one directly connects to the antenna, that's the only thing kind of remaining as a box today. Okay, after that RU, which goes to and connects to the CUDU, that's what we call, that has been cloudified. That means it goes and runs as a VM or a container in a cloud. Okay, and that in turn connects to the core network. This whole thing from the user equipment, your mobile phone, to the antenna, to the RU, to CUDU, to the core, and to the internet. That is your simplified version of telecom. Maybe I can just have a slide later. So the RAN slide, there are a bunch of projects, as I mentioned, OCUDU, SD-RAN, OAI, and for the service provider edge, Akraino is really not there. When it come to the core and cloud, right? So we have this huge list of projects. So you will have to see where do you want to work, focus upon. A lot of people would just want to focus on this layer, the infrastructure layer, right? Whereas some people who wants to go lower, they spend a lot of time on the network OS and data plane. So if your interest is in OS and the data plane, optimizing the performance, making it more faster and everything, where you work on DPDK or eBPF, you'll be working on that layer. So there are people who work on VPP, that FDIO, VPP, eBPF, P4, DPDK, they all spend time on there. Then next will be the, for the network boxes, the operating system. So in Linux Foundation, there are two projects that are dedicated for these boxes, network switches. One is Sonic and another is Dent. Dent wanted to focus on retail. It's kind of dead. So Sonic is the only one I can say for now, which is very confidently you can use. And that is the one which has really been productized. Earlier, this domain was dominated by Cisco's and Juniper's. But now that has been like even Microsoft and everybody makes switches. Okay, so network switches is not restricted by Cisco's and Juniper's now. Everybody like Nokia or even Microsoft or even like a small company, even you can go have a tie-up with somebody in Taiwan, get the boxes, take this Sonic and run and sell the switches. It's that easy now. Okay, of course, if you want to use some Broadcom or somebody's Sonic, they will come behind you, or else you're more or less good. Then if you're interested, work on the infrastructure layer, the Kubernetes and OpenStack. In Kubernetes, as I mentioned, one of the hottest topic nowadays is the networking part, especially the cloud native networking, especially for our telecom domain, to address the challenge of multiple interfaces. And we have for network control, Open Daylight. Once upon a time, there used to be like 7 to 8 companies around this Open Daylight. Now almost all are dead. But still the Open Daylight as a SDN controller, because SDN as a concept itself, I would say it's almost dying there. The controller, as of today, one of the very, very good controller, stable open source SDN controller is Open Daylight. In India, a lot of telecom companies and CDOT, CDAC, CDOT, and all, they use this, they want to use the Open Daylight because I don't know how many of you are familiar with BharatNet. Anybody have heard of BharatNet? Okay, of course. So what our government did was they laid optical cable fibers throughout our country until taluka level, some until I don't know, village headquarters level kind of. And they gave up an opportunity. From that you can create an access network and you can use that backbone of that BharatNet. But what they did was they gave this optical cable laying. You would have seen people digging the roads and laying the cables, right? These are all part of this activity, especially in rural region. Whenever they see the digging the roads and laying the cables, that's part of the BharatNet. So what they did, the problem was they gave this contract to different vendor. Different vendor laid their own optical cable and gave the controller to CDOT, doing that, hey, use this controller to control this side of network. Now CDOT ended up with lot of controllers from various vendors. Now then they came to Linux Foundation and say, hey, we are facing this issue of multiple vendors controller. What do we do? Then in Linux Foundation, we have this Orange from France. They said, hey, we also had a very similar problem. What we did, we used Open Daylight. So they put Open Daylight as a top layer controller, and underneath every other controller, we're supposed to connect to the southbound of Open Daylight. So Orange solved the problem very nicely using an open source solution. They said to CDOT, you can use it. We had connected, we had a call with them and everything. But unfortunately, CDOT said, we don't have a manpower like Reliance. Reliance is not just telecom company, it runs its own software company. It's not just small, it's a really big software company also they do. That's one of the good telcos who can compete with the AT&Ts and Verizons of the world. Right? Yeah, that's a different story. I just want to give an use case where this open source has really changed solved the problems in real world in the telecom domain. ONAP, I don't want to go too much into that. Nefio also, a year back, it was very good. Google kind of pulled out. So we don't have really much traction going on. But a lot of students are contributing and taking it up, and you're trying it out in their environment, because Nefio does everything very cloud native way. The way Kubernetes wants to do it, it decides, I don't know how many of you are, I'm assuming you're some of Kubernetes thing, defining the resources, custom resources, and creating the KRMs. And even the packaging, also they use very cloud native way. Again, each and every project discussing it takes its own whole day workshop kind of a thing that we do. So this is just a summary of all the Linux Foundation networking projects. If you have any questions or if you are interested in any specific projects thing, please reach out to me. I would be happy to help. And if you want to see how to contribute to it, what are the problems around these things, let me know. Okay. So let's. Okay. This is just a slide that Linux Foundation cannot work on its own, right? So we will have to collaborate with various other initiatives that are in the domain, and also not just for the open source initiatives, also for the specifications, standards and specifications. Because at the end of the day, especially in networking domain, right? If you create any open source project and if you take it to anybody, first question they ask is it compliant to something? Whether it's an IETF RFC, or it could be a specification from telco, it's a 3GPP, that thing, 3GPP is sitting on everyone's head. Whether it's compliant to 3GPP, or whether it's compliant to this, whether it's compliant to that kind of. So all our open source projects, right, we will have to constantly keep looking at these specifications and try to see if they can be made compliant to these things. So we will have to work with these specifications, and these are the example things that we work with all these organizations. especially in telecom domain, when you take over the open source, you should be really, really careful. Thing. Because in telecom is the only thing I would say in their specifications, these companies would add their patent technology. They will never disclose which part of it. They have something called as friend license, that they call it as a friend license. It's all friendly and everything. They say you would read the specification, you happily try to implement it, but eventually not one, lot of things would be patented technology by one of these 3-4 major players, Nokia, Ericsson, and of late Huawei. In fact, last 2-3 years, China has so much of patented technology in it. It's really scary. Unfortunately, we are really lagging it. I think IIT Madras and others, they spend a lot of money in creating our own Bharat RAN and other things, but it didn't go much. So we should all be careful when you're using open source and try to commercialize that open source in the telecom domain. It can be tricky. It's just a thing. I don't know. I'm not sure. They were, I think, Lava. Have you anybody heard of a company called Lava? They used to make mobile phones. That company got closed exactly for this reason. Ericsson came behind them. So they made their mobile phones. They created the mobile phones and tried to sell everything. It was made in India. Everything was fine. Once they start making, these companies wait until that company become really, they have money enough. Like they have this barrier like 20 million or 30 million or something like that. The moment you reach that profits and other things, then they will come behind you. Then they will come behind you for the license fees and other things. If you cannot pay and afford, you will have to close up. Lava got closed. There is two more companies, Indian companies that got closed because of these Ericssons and Nokias coming behind you. But if you're a researcher, if you're using for academia, absolutely no issue. Okay. Yeah, this is just off late over last 10 years in networking, what really clicked and what didn't click, and what's still kind of a jury is still out there, kind of, right? As I was mentioning, 5G, the cloud native networking, they're all really kind of a successful and mainstream. Especially if you want to spend time on cloud native networking, I would say go for it. Because Kubernetes is going to stay there. It will not be going anywhere, at least for a few more years, I think. And this cloud native networking is really a very, very interesting topic for you to work on. SDN, as I said, it's almost kind of gone. AI-driven networking. Networking for AI and AI for networking. Both are really hot of late thing. Networking for AI is really interesting if you're especially on the OS level, if you want to work on the network switches level, if you want to work on, that's the area. Open RAN, Wi-Fi 6. Mixed results, again, it's the jury is open, is on NFV, but going the cloud native way has helped this thing. The same thing, I just don't want to spend much on. The Nefio, this is the one example I was giving. This is just what happened like 10 years back. Telco were trying to compete with enterprises. Enterprises were way ahead with the cloud journey, right? Googles and Facebooks, they were all way ahead of cloud journey. So whereas AT&Ts and Verizon, they wanted to initially, it started as a competition. After some time, they realized we cannot really compete with these guys. We will have to better partner with them. So they tried to partner with these Googles and Facebooks and Meta's kind of a thing. Then what they did was they collaborated together through Linux Foundation. Linux Foundation was the one this kind of brought these two guys together. That's when this whole Nefio for telecom orchestration was created by Google. Okay, so Google gave the code for them, and then the automation advance was made, and today we have that Nefio. And we are still trying to push Nefio for the iOS MCN project that I mentioned that's working in India. So we are looking for contributors if you're interested in automation, automation of these workloads. Basically, as I mentioned, the biggest challenge in our network functions, especially in telecom domain, is the multiple interfaces. So placing these pods across this multiple cluster and interconnecting them across multiple interfaces. Why in multiple interfaces? If you're not familiar, don't worry. We can have a separate session on that because I don't know, for routers and switches, it's obvious, right? You know why you need multiple interfaces. But for the other telecom, it's maybe we'll have to explain sometime in detail. So Nefio is the one. I don't want to go into the Nefio. Nefio, if you're worked with Kubernetes, right? It cares all the three levels. First, very cloud native way of deploying the cluster itself. Complete cluster lifecycle management. See, complete lifecycle management of the cluster first, then lifecycle management of the applications that run on these clusters, then lifecycle management of the configuration. Okay, so now that to do all these three in a very cloud native way of doing it. So you are familiar with GitOps. I think if you're familiar with the GitOps, they do everything. GitHub is a source of truth. Keep everything in GitHub, whether it's a cluster deployment or application deployment or application configuration. Keep everything in GitHub. GitHub is a source of truth. Then you customize it and then put it in another GitHub repo and use GitOps to continuously sync with that. That's all. Very, very, if you use GitOps in any of your projects, you understand how easy it is to work with the GitHub and the projects like Argo or Flux or config sync and these kind of projects. If you haven't worked on these things, I would suggest please start doing it. Because you will eventually go to AI ops, you will have to come across these things. The next thing is on the AI for networking. So this we mentioned. As I mentioned, we are now working closely with the LF AI and data. LF AI and data is another foundation that we have on the LF foundation. So networking now have to work with LF AI and data for collaboration, for AI for networking and for both networking for AI, especially for AI for networking, for model generation. And we are trying to reuse a lot of projects that are there in LF AI within the thing. So we are calling it as a domain specific AI. Okay, we're doing the AI for a specific domain. So as I mentioned, the data sets and AI frameworks are critical for us to do. And this is the new project that has contributed from India, Infosys. So Infosys has recently open sourced their complete AI framework that they had and created a lot of models and applications and everything for networking purposes. It's called SDM. So if you are interested in networking and AI networking and you're looking for a framework to work with, SDM is the one. And Open RAN, this is the third focus I just want to see. So yeah. So if you are not familiar with the telecom network, this is just a simplified picture of telecom network. So we have a UE, your mobile phones here, and you see these antennas everywhere. First thing that antenna gets connected to is the RU. So whenever you place a call or send any message, it goes to those antennas next to the RU. From RU, it goes to the RAN network. Okay. From RAN, it goes to the core. From core, it goes to the internet. Typically, or the backbone of the telecom. For example, if Airtel, if it's a tower belongs to Airtel, it goes to the backbone of the Airtel. Or if it has to go to out of this country, it can go to the internet. Then again come back to the core, then to the RAN, then to the RU, then to the other mobile phone. So this is kind of a flow that happens whenever you make a call or thing. So if you're not familiar with these things, you can go out today and try to understand this network, how this network is there in your locality. In your locality, within here, where is whatever the tower, where is it ending, and how is this being managed, kind of thing. So if I would request, if you are still interested in this domain of this telecom network, please go and talk to this BSNLs or Airtels that are there nearby, and try to see this actually in working. Okay, how this telecom exchanges have become data centers. They may not allow you inside the data center, but at least you will see that, hey, this is where it is landing first and this is where it's going. In fact, on Google, you can see how all these countries are connected by optical cables under the sea. You would have seen, if you're not seen the under the sea cables, please take a look at. So as I was mentioning, deploying a 5G network today, it's a day's job if you have the hardware. Okay, before like 20 years back, it would have impossible. It only like Nokia's and Ericsson's controlled everything. Okay, now in I go to one college once a week. We have deployed our own private 5G there. Okay, but it's a rural college. Nobody is using it, unfortunately. But in this college, like NITK and everything, if you have a private 5G, I'm pretty sure both the kids, not kids anymore, both the students and teachers, both will be happy to use that or do the research on that particular thing. And that is the way I have seen 5G network, right? It can bring all departments together, because there are various problems starting from power thing where electrical engineering can work on, or the design of these data centers and everything. And of course, electronics and CS variants can always work on the AI problems related to that. And if you're really interested in the telecom side of it, especially on the RAN side, lot of the previous thing, the new trend in this RAN is, as I mentioned, there is a SMO layer which controls the network. That is where all the AI things are happening. In fact, there are apps that are called as D apps. Don't worry about it if you're not familiar with. Basically, these are AI apps that sit near your tower itself, kind of a thing, as close to your RU, as close to your RUs or as close to CUDUs, and do the intelligent things. Especially in for when things go, and if your people wants to support VR, AR, VR, or high-speed traffic managements and all those things, all the AI things will be coming to the edge. Yeah, so this is all our open source software today. You can use it to deploy your 5G network or a private 5G or a private 6G going ahead. Okay, so if you have servers thing, maybe you should have one in your college also. If you're interested, please, my request is to consider deploying a simple private 5G with some servers and RU unit and try to do research in the domain. And as a faculty should focus on specifications. Faculty should not spend on getting their hands dirty, because we need them to contribute to specifications. India needs you to contribute to telco specifications, especially our academia. It should not be restricted to IITs or ISCs kind of a thing. Even NITK, who have a very good faculty, should do that. Yeah, I think that I don't want to go into details of each of this thing. I will stop here. If you have any questions or comments or criticism, please let me know.
Big round of applause for Sridhar.
Go ahead.
So yeah, we are running a bit short on time. So just a couple of questions. I think one Vineet wants to ask, maybe one there. So can you just give the...
I will take the dirty money first. Is it money or monkey? No, I was joking, that's all.
Yeah, you talked about the horizontal and vertical slices. Could you talk more about what differentiates between the horizontal technology and vertical technology?
Horizontal ones which applies to multiple foundations, like AI as a horizontal, and another thing is OpenSSF. It's a foundation which is a horizontal foundation that focuses on security and security badging. Okay, so there are open source projects that scan all these repos and give a security badging to these repos, right? So that's a horizontal that applies to all the vertical foundations. whether it's a networking or whether it's I don't know, finance, financial thing, or a banking, or entertainment, any vertical domain, right? This horizontal security applies to everywhere. So OpenSSF, AI, telco, AI, cloud, they are all horizontals.
I see. I had also this one more question that you talked about all these technologies, but me and I don't think a lot of people here understood any of
I know.
that means. So could you please brief us about where can we learn more about this?
This instance, telecom,
This entire field,
the
the
networking.
domain, yeah, the domain itself.
Can I take that?
Go ahead, please.
No, actually, quite a few people understood it. But this talk was very important because this shows that we are not clearing our system's fundamentals clearly.
I see.
Correct? Operating systems, database systems, computer networks, fundamental courses. We are not focusing these days. We are only driven by a few subjects like data structures and algorithms because that's important for companies, that is called FANG or whatever. And we are only worried about AI and the set of AI tools. So the bigger problem that we are facing as faculty is a lot of people actually keep asking, how come you are getting students who are working on systems and networking? Because my students work on all of these things what you saw just now.
Oh, I see.
So tomorrow workshop itself is on Kubernetes. One full workshop for 110 minutes. We have circulated that information is on what Sridhar was talking on Kubernetes. So if you don't know and have you never spun pod or something that you have never done, just come with one machine tomorrow. And if you don't know how to install Linux, there's a Linux installation workshop. So you can get the Linux installation done and then go to the Kubernetes workshop and then play around with a couple of pods, because you as the young generation kids need to understand that why AI/ML is important. The base below it which is going to run is basically systems, and the efficiency and every ounce of the CPU cycle that you consume or GPU that you consume, you need to understand systems in detail.
Models have to run somewhere.
The models have to run somewhere, correct? So this, right, so this is the reason we had a deep tech talk like this, that at least like you said, a lot of people did not understand, but now you know such things exist. So at least something fell on your ears today, and now we will be sharing this slide deck also.
Yeah.
And you can at least now there is something called RAN, there is something called private 5G. Maybe you are not able to consume all of it, but it's okay. Maybe over the another few months from now you will be able to consume it, but at least now you heard such things exist. So that's something that I thought I will take the question.
Sure. Thank you for the answering questions.
All right. I think we had one more question from Vinith. I think we can take that and close. So
Yeah. So my question was, like, Lava is back to the market right now after quite of a break.
Correct.
Like, what change did they do to come to the market?
They ended up paying the FRAND license.
Okay.
These guys, Nokia's and Ericsson's, will not leave you if you become successful.
So they did not change anything. They just paid. And
They will never change anything.
thank you.
So Vinith and the boy who asked this question, just last week I was in Bangalore, and one very good scientist from Nokia came and gave a fantastic talk on 6G. And I said, great, you are talking about 6G. I want to do an end-to-end simulation of 5G for my students in my class, and I do not have any tools. Everything is proprietary, everything is commercial. How do I show an end-to-end demo to my student? Do my students know from the phone how does a WhatsApp message get actually delivered to their friend? Can they give me a life cycle of it? They cannot. Okay, I want them to visualize it. If I can do a simulation, I can explain to them, see, this is how the packet goes out from your phone, then it goes to the base station, then it goes here, then it goes to EPC and stuff like that. But I want them to simulate. Where are the open source tools? He said open source and telco, they don't. So he said that you will not ask for open source tools from us because we don't want it. We don't want it. Because if I give you my tool, right, then you become a champ on that which we don't know. We want to keep our USP with me. Open statement. They do not want. And even today, you take a look at it. There are a few tools of 5G available, but you can never do an end-to-end simulation from a UE to another UE and back and see back and forth how exactly the packets go through we don't have that visibility into the network. Only these telco players, the core players. RAN is trying to do a lot of work. NFV tried helping us in the core part.
But open source we can still do now.
We can still do now.
Yeah.
And I think IISc has a very good a stack which
Correct.
Pamela madam has made, right?
It's all from Linux
So
Foundation.
It's
projects.
all from Linux Foundation. So we are talking about 6G, but my students don't know still how to visualize an end-to-end. Forget about 5G even. 4G end-to-end simulations only limited people can do. So unfortunate, but that's the way it is. But yeah, thanks a lot, Sridhar.